Hello and welcome. My name is Pasabachala and I'm a Principal Solution Engineer here at Snyk. Welcome to CyberCon 2021. In this presentation / demo today, we're going to look at how we can automate container runtime scanning in terms of security with Snyk. So here we're going to be focusing on the containers while they're running in a Kubernetes cluster. Of course, you can scan containers by connecting to a registry, as well as scan the open source dependencies of application artifacts sitting in source code management or even on using our CLI. But here we're just going to focus purely on runtime with Kubernetes. So I bring this side up a lot when I talk about Kubernetes and containers. And what a lot of organizations are struggling with is how can they add some governance around how containers are created? Because you've got multiple teams that may have different needs. They may specifically be deploying containers that are Java applications, Ruby applications, and then they've got to work out what's the right base image that they need to use. Do they need to add some user instruction layers as well? And then what happens when we finally have these containers created and different teams are using different base images and we need to update them from a security perspective? Is there some governance around that? Is a specific team meant to do that? What about the code and the dependencies? What about maybe potentially using a base image with common software? These are all thought processes around how we're going to roll out creation of containers and how we run those containers on Kubernetes. And so a lot needs to go into how we create those containers, how we update those containers, specifically from a security perspective, because when we are creating containers with application artifacts, our actual risk posture changes where there's more of security entry points through a container than there are an application running standalone, for example. And so a lot of this around vulnerabilities and how to quickly remediate, as well as what's the best way to create it, is what this slide's really telling you. Is there's a lot to think through here in terms of how you create your containers, how you patch them, how you update them, and what are the various teams going to do to make it easier to potentially roll out security updates if everyone's using different base images, for example. So those are the things that you need to think through as an organization. So what do we mean when we say Kubernetes application security? Because we're talking about containers running in Kubernetes. And what that really means from Snyk's perspective is vulnerabilities in the container images. So that's the priority code that you write yourself, your own proprietary code that is your custom IP, if you like. We also scan the application dependencies themselves. So if you're using Java, for example, that's your pom.xml or your Gradle, build.gradle file, or if it's a JSON application, it's your package, an NPM application, it's your package.json. But we also scan the container operating system and the Linux packages themselves, which are normally dragged in through the base image itself. But there's one important distinction when it comes to running applications on Kubernetes, and that's also infrastructure as code misconfigurations, because ultimately you decide how you deploy your application, and this can just drastically increase the blast radius of potential exploits as a result of this. Even simple little things like potentially running the container as root versus non-root. Simple things like that. Or are you setting CPU or memory limits? If not, potentially that's a security problem. And there's many more to those. We'll see that during the demo itself. So what does Snyk's container monitor capability actually do? So we actually scan the container image associated with each workload and then look at the vulnerabilities of those themselves. When we think of workloads on Kubernetes, there's a lot of different ways to deploy workloads. Whether you use the standard Kubernetes deployment, you could use replica sets, daemon sets, even stateful sets. You could just be running a job itself. You could be running a cron job, replication controller, or just running a pod, just a simple pod without a deployment around it, for example. And so this is what we mean by workload types. In Snyk Kubernetes monitor capability, we can scan any or all of those, or in the demonstration I'm going to show you today, we constrain which workload types we really want to scan here, because ultimately a job, which is a short-lived process, may be something that we don't need to scan, because ultimately once the job's finished, that container is then shut down. We prioritize vulnerabilities based on runtime configuration as well, and I'll show you that in the demo itself. That's where we're starting to talk about how have we rolled out this deployment? What decisions have we made in our Kubernetes YAML file, our Helm charts, for example? And then we monitor for new vulnerabilities by rescanning daily and alerting. And that's just a constant thing that just keeps happening over time. So if you think this through, if your container is running a production workload, over time, open source vulnerabilities or Linux operating system vulnerabilities can start to surface if that container hasn't been patched and redeployed. Or potentially it could have been patched and sitting in a registry, but no one has redeployed the application itself. And so this gives you the capability to see what's happening at runtime while you're running applications in Kubernetes in production itself. So how do we onboard Kubernetes workloads to Snyk? In this demonstration, we're going to see how to automate that. But having said that, we can just manually through the Snyk UI using the Kubernetes integration, just automatically through the UI, indicate which workloads we want to monitor in Kubernetes. We can use the Snyk API to import those Kubernetes applications themselves. We could also add an annotation as follows: org.k8.snyk.io/v1 to a workload. You can add that annotation to a deployment, a job, replica set, pod, etc. You can add an annotation to an entire namespace. You might have specific namespaces, and in those namespaces, you want to monitor every application that's running in there. So that's another way. But what I'm going to show you in this demo today, which I think is a little more powerful, it gives you more capability in terms of determining exactly what type of workload you want to run. We're going to define a custom policy using Rego, which is part of the open policy agent itself. So I'm going to do that in today's demo, and I'm going to show you what that looks like. So today's demo looks something like this. So on the left-hand side, we've got Snyk that's monitoring our Kubernetes workloads themselves. We're connected to Docker Hub's container registry. We're connected to GitHub, where the source code for our application exists. And in the Kubernetes cluster, we deploy something known as a Snyk controller. If you've ever used the K8's operator pattern, something similar to that. And that Snyk controller will talk back to the Snyk UI and tell it about which workloads are available in the Kubernetes cluster that are potential candidates that we can start to scan for vulnerability issues. Again, in this demo, I'm going to use the Rego policy language itself to define exactly what is getting picked up automatically. I don't want to manually add any workloads. And in my example today, as the operator that's operating the Snyk controller and the GKE cluster itself, which is what we're demoing today, Kubernetes cluster on Google, I determine the namespace and the type of workloads in that Rego policy language file itself. And as I said, on the left-hand side, you get a viewpoint here into what's happening with your Kubernetes workloads. That's just a sample screenshot, but we'll show you in the demo exactly what it looks like, how we continually scan daily and what we're getting from a scan, not just the Linux vulnerabilities, but also the open source dependencies, if applicable, we'll scan those as well. And we'll also look at how we've deployed the application. What does our IAC configuration look like on Kubernetes? And is that a potential for security vulnerabilities itself? And we'll highlight that and show you exactly how we do that in the demo itself. So let's switch to the live demo itself. I'm just going to escape from here. I'm going to go to the Snyk UI itself. So you'll see here that I'm connected to Snyk, and I'm already monitoring some actual deployments on my Kubernetes cluster as well, and they're tagged as GKE cluster. So if I look at those applications that are running on Kubernetes, what you'll see is that we know what the image is because we already know that based on when we describe the deployment, for example. In this example we're looking at here, we know exactly what container image that we're pulling down and running. And you can see here it scanned the base image as well as any open source dependencies it's found. In this case, it's a Spring Boot application, so it's looked for Java jar file dependency files. And you get best of both worlds when you do that. So if I was to go into the base image itself, we can see here that we auto detect the base image and determine the amount of vulnerabilities that are there, and then give you capability around what could you potentially upgrade to reduce the amount of vulnerability. So by choosing any of these minor and major upgrades, we can go from 29 vulnerabilities to as low as 14 here. And not only are we only have 14 vulnerabilities, but they're all considered low vulnerabilities. And so all of those vulnerabilities are surfaced and described here in terms of what the current status of that base image is. So let me go back into the projects view here. And what I'm going to show you here is this Spring Boot application itself. Instead of clicking at the base image or even the open source dependencies, I can go at this top level deployment object and click on that. And when I do that, I get this added benefit of being able to see from an IAC perspective, how was this application deployed? And we can see here on the right-hand side that from a privilege perspective, that passed, and you get a little context as to what that means. CPU limits, that didn't pass, so we failed to set any CPU limits, and it makes it quite clear in terms of what that is. The container.resources.limits.cpu is not set. Same with memory limits. This container is run as root, so it's not run as non-root, for example, so that's another potential issue. We've specified that it's not a read-only root file system as well, so that's another potential capability, and we haven't dropped any Linux capabilities at all. And the question is, do we really need those Linux capabilities? Potentially not, right? So there's the things that we're highlighting. And then on the left-hand side, you get the ability to either choose those open source dependencies or the base image if you just wanted to drill on seeing specific vulnerabilities. So here I'm looking at, by clicking on the workspace/boot info folder, I'm looking at the open source dependencies and seeing what exists there at the moment in the application. And also in this container application that's running in Kubernetes, we also get this concept of a priority score, and that looks at whether there's a fix available. And again, it starts to look at all those IAC configurations that were set in my Kubernetes YAML file. So there's no container memory limits, there's no container CPU limits, excess system capabilities, all that result in running as root, writable root file system, and as well as the CVSS score, resulting in a priority score from 0 to 1000. And that's how we prioritize which issues appear higher versus the ones that appear lower. So why don't we then, now that we know we're monitoring this Spring Boot application, we also found a MongoDB container as well, sitting in our namespace. And I'll show you why it's picked that up as well. So what I'm going to do here is I'm going to switch to a terminal window here, and this is my Kubernetes. So if I do kubectl, I'll get namespace here. We don't have many namespaces here, but what you'll see is that Snyk monitor that I spoke about. We see that. We also see an apples namespace, and in the apples namespace, if I do a kubectl get all -namespace apples, you'll see in here, this is where you'll find that Spring Boot application itself, and you'll also find the MongoDB instance. I've told the Snyk controller that anything that it finds inside this apples namespace, automatically go and monitor that in Kubernetes. So that's why those are already available in the UI itself. And so if we have a look at that kubectl get all -namespace Snyk monitor, for example, this is where our, oops, spelled that wrong. This is where our Snyk controller is running. You can see here just one single pod running as a replica set, and that is what is connected into our Snyk UI. And so this is something that's running inside the cluster itself. And so if I go back to the UI here and go to integrations, what makes this possible is an integration ID for Kubernetes. So if I was to go into the settings of that, that's my integration ID, and that is what gives me the connectivity into my Kubernetes cluster to be able to import workloads, for example. So now we've got that, and we're actually already monitoring some Kubernetes application. Now you've seen how the Snyk controller is sitting in the Kubernetes cluster. That's pretty easily installed using Helm, which you see from this example here. It's very easy to install, just a couple of steps and you'll get the controller installed. And then what we're doing is we're automating the import and deletion of Kubernetes workload projects by using a Rego file. And this is something that's beta at the moment, but it will soon be GA. And so that's what we're demoing today, how we're going to automatically define through the policy syntax of a Rego file what type of workloads that we want to actually import automatically. If you look at this basic example here, anything that's in the namespace default is automatically going to be imported into this cluster, and any type of workloads that we described previously when I was showing the slides. So if I go back to here and we look at that file itself, it's a pretty straightforward file. So you can see here that I'm looking for anything in the Apple's namespace, but then I'm constraining it to, if we find something that's just a job, a pod, or a cron job, we don't want to auto import that. So we'll be importing deployments, replica sets, stateful sets, all those type of workload objects. So now that we've done that, let's actually go and deploy a new workload. So what I'm going to do is I'm going to switch to another terminal window here, and I've got something called Pet Clinic. So if you just look at that, Pet Clinic is just a basic deployment. It has a load balancer over the top of it as well. And we're not really defining anything here. We just want to run this workload itself. So I'm just going to do kubectl apply Pet Clinic. And so by doing that, I do kubectl get all -namespace apples. I've specified the namespace apples that I want it to run in. And you can see now Pet Clinic's already running. What I'm going to do before going to the UI is if I run a command as follows, because I know I've got a controller running in this Kubernetes cluster. So I'm just going to get the pod, the name of the pod, by using a little bit of this kubectl command here, and just grepping on the JSON object itself just to find out what the pod is so I can monitor the logs, right? So if I do a Snyk, Snyk. And so here you can see I'm monitoring the logs of the controller itself once the logs start to appear. And you can see here that one of the last things it's done is it's actually processed the Pet Clinic application itself. So knowing that and knowing that it's been processed, I'm going to assume now that it's automatically going to get added as a project. So I'm just going to do a refresh on that. And we see now that the Pet Clinic application has automatically made its way to the Snyk UI. So that's great. That's exactly what we wanted in terms of our setup. And so if I drill into this, you'll see something very similar to before. Again, we know what the workload type is because we specified in the YAML file itself that we wanted to deploy this application here that's sitting in my Docker Hub registry. And it did an open source scan as well because Java supported for that. And again, if I click at this top level here for Pet Clinic, you'll see that with this, if you remember when I showed the YAML file, we weren't setting any CPU limits, memory limits. We weren't telling this application to run as non-root, the read-only file system, or dropping Linux capabilities were all not defined. And so that's exactly what we're expecting there, and that's what we see. So having said that, what we're going to do now is I'm going to run a Snyk IAC scan against that, because obviously the Snyk platform already knows this hasn't been deployed correctly from a security perspective. So I can just do that by saying Snyk IAC test and test that Pet Clinic's YAML file itself. And you'll see here you'll get similar output that's already showed in the UI. So again, we're not dropping any default capabilities. We're running with privilege escalation control, not running without root. We do have root control in this, and a couple of other bits and pieces around a liveness probe, memory, CPU. So this is where we're already getting a viewpoint of what this deployment is going to look like before I've deployed it. So that gives us an opportunity to fix that issue. So what I've done here is I've created what I'm calling good. It's not quite good. It's just a little better than the last one. But here you can see now when we look at this deployment, we're actually setting some memory limits, request limits, and we're running a security context object. And in here, we're specifying a user and a group. We're making sure that the read-only file system is true. We're saying run as root is true in this example here, but ultimately I'm dropping all the Linux capabilities. So you get this ability to start to now define a better config than what you had previously. So let's go and deploy that. Again, this won't be exactly what we want. It's not fixing all of them, but it's getting better in terms of where we want it to be. So if I apply -f, this time we'll call it good Pet Clinic. So we're just giving the application another name. We're using the same image here. And once it does that, it's going to create the necessary objects on Kubernetes. And this monitor you can see is already started to pull down the Pet Clinic. What I'm calling Pet Clinic good is in terms of the workload name. It's still the same container. And so ultimately, once it's done that and scanned that, then that will appear in the UI as well. And you can see now it's already gone and said it's processed that image. When we say process, that's where we do our Snyk container scan and we test the base image vulnerabilities as well as any open source dependencies that we can obtain within the container itself. Again, we're testing directly in the container registry. So we're testing against the OCI container itself, right? Nothing. We need to go and drag that out to be able to verify what's inside it, right? So we're not doing any file system scan here. So if I do a refresh here, we should get Pet Cleaning is good as well. Now, when I say good, it was better than the last deployment. It's still not perfect, but now when I click on this, we'll start to see that a few of these things are now passing versus previously that they weren't set. The only thing I haven't done here is set the CPU limits. Maybe that's something that you may not want to set, but obviously that's good practice as well. And then the priority score will rectify, will highlight the fact that these have now been done. And so it's a lot less factors contribute to this priority score that you're seeing now. For example, the only real thing we've done potentially wrong from a security perspective is not set the CPU limits on this application itself. So now if I just go back into here, so that's still getting monitored, and I say kubectl get all dash namespace apples. You'll see now that we've got a couple of different versions, pet clinics running, one called good and one called the one that we previously deployed. So they're running. As a result of them running, we can automatically pick up those containers and then automatically add them as workloads. And that was all done by using that rego policy file, which was determining what should be picked up versus not be picked up, but it's automatically done. If I wanted to import manually, I could go to integrations here, so not use the auto capability, go into the Kubernetes tile here, and I can see all of these workloads. Again, this is going to go across all namespaces in your cluster, not the obviously system ones, but yeah, so you won't see the kube namespaces themselves, but the Apple's namespace and Snyk Monitor are ones that come up, and I could then go and import these if I wanted to. The other thing I wanted to show, which I haven't shown at the moment, is for each of these scans, they're considered individual projects. So this is tested daily. If I go into the base image itself and go into the settings, this container image, base image itself project will get tested daily. You can turn that off or test weekly if that's what you wanted to. And that's what I wanted to do. That's what I was referring to, is over time, you can start to see what your security posture looks like. Even though the application at the time of deployment had very few vulnerabilities, was using a good base image, over time that will change as vulnerabilities start to appear. And so this is where you're mitigating the risk to the businesses. You're looking at these containers that are running in Kubernetes at production to ensure that someone is going to try and remediate these issues so that they don't exist for a long time, if they haven't already been done in the software development lifecycle and been patched previously and then rolled out to Kubernetes itself. The last thing I wanted to show is this concept of reporting as well. So here we've got all Kubernetes workloads. We could just go to the reporting tab itself. And here we get a viewpoint of the issues that are actually in the Kubernetes cluster itself. And we get also some graphs as well. And so I'm going to let these graphs actually, so this is using our Snyk API under the covers to pull this data out. And I'll let that load. But what we can do as well here under projects is actually just drill into a specific application that's running on Kubernetes and just view the report for that itself. And so here we only want to look at and we see that these are automatically selected, these two projects for that Spring Boot employee deployment, and then we get some graphs just on that in terms of how many test run projects, new issues, fixed issues, and then our issues over time and exposure window as well. These graphs can take a little while to display, but eventually they will display. And so we could then just turn that off if we wanted to and just go back to projects here and just go to the reporting as a whole across everything in this Kubernetes organization in Snyk itself. So hopefully that gives you a feel for what we can do from a runtime perspective with Kubernetes. So here, what we've seen is we've installed a Snyk controller in GKE. We've connected that Snyk controller up with the Snyk UI. That gives us the integration into the Kubernetes cluster. We could manually import those workloads, but today what we've done is we used a Rego file, and in that Rego file, we determined exactly what we want to auto import. And so when we installed the Snyk controller, we specified that custom policy file itself so that the controller knew exactly what it should import into the Kubernetes cluster. And the other thing that's probably worth highlighting as well is the auto import also would delete when we decide we want to delete workloads. So if I do kubectl delete -f, whoops. Let's get rid of the good pet clinic application here. So what that will do, and again, the monitor is just constantly looking at what's happening on the cluster. So it's going to now remove that pet clinic application. So we're just waiting for the service to come down. But if I was to remove that good pet clinic application, it should now have disappeared from the UI itself. And you see it's gone. We've still got the remaining pet clinic application because I haven't yet deleted that one. This is what we mean by auto importing and auto deleting workloads by specifying what that policy file looks like. And so if I get that, the policy file again, just so that you can see what that was, is actually just looking for anything in that namespace apples. That's where all of our deployments are occurring, and then looking at what the type workload types are and just making sure we only monitor those workload types that we've told it we can monitor. And that's the same thing when we delete. That's why that has now disappeared. So in closing, let's just finish with one more slide. Hopefully you like what you saw today. If you do, just go to snyk.io. We have the ability to just sign up for the free tier. From the free tier, you can do all sorts of scans, open source scans, IAC scans, code scans. Kubernetes itself requires you to talk to Snyk to enable that integration. That's not enabled because it's part of our enterprise capability, so that's not enabled, but you can just talk, you send me an email or contact Snyk and they can do that for you. A couple of related links as well to go and check out how to install the Snyk controller, as well as how to set up the automatic import and deletion of Kubernetes workload projects themselves. Or you could just go to support.snyk.io and click on Snyk container Kubernetes workload and image scanning itself if you wanted to find out more, or even replicate this demo itself. It's quite easy to get up and running, and you can start to get value out of running Kubernetes workloads and scanning them for vulnerabilities at runtime, which is what we provide with Snyk Kubernetes integration.